Okay, so today we're going to look at conditions for special parallelograms. In other words, if I give you a figure, how do you know for sure that it's a rectangle or know for sure that it's a rhombus if you're not just told that it is? So here are the conditions for rectangles. The first one is the definition. If it's a quadrilateral with 4 right angles, it's a rectangle. That's the most obvious one, I think. The next two, it's got to be a parallelogram first. So you have to know that it's a parallelogram. How do you know it's a parallelogram? Well, there were 5 ways to know those. If you don't know those yet, you got to know those for this next test. So those are if both pair of opposite sides are parallel. That's the most obvious one. If both pair of opposite sides are congruent, it's a parallelogram. Yes?
Is this the next unit?
Yeah, this is part of the next unit. If one pair of opposite sides is parallel and congruent, both pair of opposite angles are congruent, or if the diagonals bisect each other. Those are the 5 ways to prove that it's a parallelogram. If you can prove it's a parallelogram first, and any of the angles is a right angle, it's going to be a rectangle. Why is that? Well, because the opposite angles are congruent, so that's 2 right angles, and the consecutive angles are supplementary, so that means they add up to 180, so the other angles are right angles. You're going to get 4 right angles. The other one is if you have a parallelogram with congruent diagonals, it's got to be a rectangle. In an ordinary parallelogram like this, you've got a long diagonal and a short diagonal. But if you have a parallelogram where the diagonals are the same length, it's got to be a rectangle. It's the only way that that can work. Right? By making the diagonals the same length, you make this have right angles. And this is actually, believe it or not, how you test if you're building something. So I do some carpentry and some furniture building. And one of the things that you do when you build something is you can check to see that the outsides are all the same length. And the way for big pieces, like if you're building a wall, you actually measure from corner to corner and then from this corner to that corner. If they're not the same, the angle's not a right angle. You don't get out a little tiny protractor to check to see if it's a right angle if you're building a wall. And if it's not, if it's leaning like this, you literally get a great big hammer and you wail on it until it moves over, until it becomes a rectangle. Okay? All right. Conditions for rhombuses. Again, the most obvious one is the definition. If it's a quadrilateral with 4 congruent sides, that makes it a rhombus. And I know this didn't print very well on yours because it's not very dark on mine either. That's the definition. If you know it's a parallelogram first, there are 3 different ways to know that it's a rhombus. One is to know that the diagonals are perpendicular. Right? Remember I talked to you about taking your diagram and turning it up like this? If it's a parallelogram and the diagonals are perpendicular, then you know that it's got to be a rhombus. If it's a parallelogram in which the diagonals bisect the angles of the rhombus. So in an ordinary parallelogram, the diagonal doesn't bisect the angles. But in a rhombus, all 4 of those angles will be the same. And then the last one is if you have a parallelogram with 2 consecutive sides. Do you know what consecutive means? Who can tell me what consecutive means? Yes. Yeah, one right after the other. So if you're going around the figure, if you know it's a parallelogram and you know, say, these 2 sides are congruent, it's got to be a rhombus because the opposite sides are going to be congruent all the time, and that'll get you all 4 sides congruent. And for a square, rather than listing a whole bunch of things, you got to know that it's a rectangle and a rhombus. If it's a rectangle and a rhombus, it's going to be a square. All right, let's go on to page 2. So this is that wall I was telling you about a moment ago. So when you build a wall for the house, this is basically, not counting windows and doors and stuff, how it's done. A wood wall is built for a house so that XY, this side up here, is congruent to WZ, and XW, this side, is congruent to segment YZ. Let's stop right there. If I know this top is congruent to the whole bottom, and I know the right side's congruent to the left side, what do I know it has to be? What kind of a figure has both pair of opposite sides congruent? Less specific. Less specific than that. This is, I mentioned it a couple minutes ago. If both pair of opposite sides are congruent, it is a, what is that? A parallelogram. So when we stop after this first sentence, we know it's a parallelogram. Once the wall is assembled, this should be, please change this to XZ. I apologize. XZ and YW are measured and found to be congruent. Why must the frame be a rectangle? Well, so since XY is congruent to WZ and XW is congruent to YZ, WXYZ is a parallelogram because when both pair of opposite sides are congruent, we know we have a parallelogram. Then XZ, that's a diagonal, and YW is also a diagonal. So since XZ is congruent to YW, WXYZ is a rectangle because a parallelogram with congruent diagonals must be a rectangle. So the first step is always, do we know that it's a parallelogram or not? Sometimes they'll tell you, sometimes they won't. And then after it's a parallelogram, you need to see, does it have the other qualities that we need? Any questions about that example? Yeah, that's fine. You good? Okay. Yeah, anytime I move before you're finished copying, just let me know. Okay, let's take a look at this example. Determine if the conclusion is valid. If not, tell what additional information is needed. So let's look at this one. We've got AB congruent to CD, and BC is congruent to AD. If I know those two things, what do I know? What do I know about ABCD? If these two sides are congruent, and nope, this is all I know so far. These two sides are congruent, these two sides are congruent. It's a parallelogram. If both pair of opposite sides are congruent, it's a parallelogram. Then it tells you that AD is perpendicular to DC. Tells you that's a right angle. If it's a parallelogram that's got a right angle, what does it have to be?
Square.
Nope. Look back at your notes. It's got to be a rectangle. It absolutely has to be a rectangle. If it's a parallelogram and it's got a right angle, it's got to be a rectangle. And then this says AC is perpendicular to BD. AC is perpendicular to BD. So the diagonals are perpendicular. What kind of a parallelogram has perpendicular diagonals? Again, look back at your notes. A rhombus. So now I know it's a parallelogram. I know it's a rectangle. I know it's a rhombus. It has to be a square then. So this is valid. Yes, Peter? Yeah. All right, let me clear all that up. Let's say this is all we know. AB is congruent to BC, and AC is perpendicular to BD. Your first step is always, do I know that that's a parallelogram? Is there enough information there to know for sure that that's a parallelogram? No. So I can't decide that it's a rhombus. This is invalid. What additional information is needed?
Get like AD, DC, AB, DC equal each other too.
Yeah, there's lots of things you could say. I think the shortest thing, I mean, you're not wrong, but the shortest thing to say is we need to know that ABCD is a parallelogram. If it was a parallelogram and the diagonals were perpendicular, of course it would be a rhombus. All right, let's look at this last one in this section. If AB is parallel to CD, let's stop there. Do I know for sure it's a parallelogram yet? No, that's not enough. AB is congruent to CD. Do I know it's a parallelogram now? Yes, I've got two sides that are parallel and congruent. So at this point, I know it's a parallelogram. And I know that AC is perpendicular to, is congruent to BD. Which of the parallelograms has congruent diagonals? Pardon? A rectangle, that's exactly right. So this is valid. All right, page 3. So here, use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or a square. Give all the names that apply. Want you to notice it told us that it's a parallelogram, so we're not going to have to do that first. It's already taken care of that. So we need to look at two things. We go back up here at the beginning of your notes. Perpendicular diagonals makes it a rhombus. Congruent diagonals makes it a rectangle. So we need to check both of those things. We need to check to see, are these two diagonals congruent and are they perpendicular? I'll just tell you now, it happens every year. Somebody graphs this looks at the graph and says, it's this. And that gets you, maybe a point out of 5, even if the answer is right. Because you haven't done what it said. It says use the diagonals. So if you're just looking at it, that's not good enough. Should you sketch a graph? Yeah. So let's do that. These are all positive, so I only need the first quadrant. So A is at 0, 2. B is at 3, 6. C is at 8, 6. And D is at 5, 2. So which of the special parallelograms does this look like? It looks like a rhombus. Do we know for sure it's a rhombus right now? No. It said use the diagonals. So I suspect it's a rhombus, so I'm going to start with, are the diagonals perpendicular? I'm going to switch colors on this. So here's one diagonal. Here's the other diagonal. Do they look perpendicular? Yeah. Is that enough? No. So what I need to do is find the slopes. So from B to D, the slope of BD. We go down 1, 2, 3, 4, and to the right 2. So that's -4 over 2, which is -2 over 1. The slope for AC. From A to C, we go up 1, 2, 3, 4, and to the right 8. So that's +4 over 8 is 1 over 2. Earlier this year, we looked at lines that were perpendicular. What needed to be true about their slopes? It was 2 things. Yeah, they need to be the reciprocals. They need to be flipped over, and they need to be opposite signs, and they are. So the diagonals are perpendicular. So I know that this is a rhombus. I also need to check, even though it doesn't look like it, I need to check to see, is this a rectangle? To check to see whether it's a rectangle or not, I need to check to see if the diagonals are congruent. Let's switch colors again. See how I can make an easy right triangle out of this? That's the slope triangle. I can do the Pythagorean theorem to find out how long BD is. I already know these two distances. I've already counted them. It was 4 and 2, right? So the length of BD squared is going to be 4 squared plus 2 squared, which is 20. So BD is the square root of 20. By the way, you don't need to spend any time simplifying the square roots. We're just seeing if they're equal. So it doesn't matter. And then let's do the same for AC. From A to C, I'm going to draw a right triangle up this way for AC. And again, I already know these two distances. This distance is 4 and this distance is 8. So I've got 4 squared plus 8 squared is AC squared. There's no way that's going to come out to be the same as this other one. But let's go ahead and go through with it. Let's see, that's 16 plus 64 is 80. So AC is the square root of 80. So segment BD is not congruent to segment AC. So this is not a rectangle. So my answer is it's just a rhombus. Let's do one more of those. So we'll graph it first. So E is at -4, -1. F is at -3, 2. G is at 3, 0. H is at 2, -3. All right, I'm going to go through exactly the same steps in the same order as I did them on the last one. I'm going to first check, are these two perpendicular to each other? They sure don't look it, do they? But again, we're not going by looks, which is a good thing for me. So the slope, yeah, I did. I just called myself ugly. So the slope of FH, see, we're going to go down 1, 2, 3, 4, 5, and to the right 1, 2, 3, 4, 5. So -5 over 5 is -1 over 1. The slope of EG, go up 1 and to the right 1, 2, 3, 4, 5, 6, 7. Are these perpendicular? No. FH is not perpendicular to EG. So this is not a rhombus. We really didn't think it was, but now let's check to see whether it's a rectangle or not. So let's see if I draw in that triangle. Again, I already know those two lengths. If you want to not draw it in, you can just use the numbers that you used from your slope before you reduce them. Don't use the numbers after you reduce them. So we're going to have 5 squared plus 5 squared is FH squared. So that's 25 plus 25 is 50. So FH is the square root of 50. For EG, if you want to draw it in, you can, but we already know that's 1 and this is 7. So I've got 1 squared plus 7 squared is equal to EG squared. Well, that's 1 plus 49, that's also 50. So EG is the square root of 50. That means that FH is congruent to EG. And a parallelogram that has congruent diagonals is a rectangle. If it's a square, it's going to be both a rectangle and a rhombus. Okay, any questions about that example? Yes, ma'am.
Would it ever be like neither?
It's possible that it can be, and if it's neither, you just say it's just a parallelogram. It's a good question. Any other questions? Okay.